All right, so this video will focus on 3.2. And the first thing we're going to do is talk about acute, right, obtuse, or straight. And if I look here at this angle 1, this is a right angle. And the thing that really identifies it for me, the way I know for a fact, is this little square right here. This right here means that it's a right angle or 90 degrees. Now, if an angle is smaller than 90 degrees, it's so cute. It's like a little one. So we just call this an acute angle. If a line or angle is greater than 90 degrees, it's obtuse. So it's more than 90 degrees. And of course, if it goes straight, it is just a straight line if it's 180 degrees. So our next one is kind of our essential question. How can you describe the relationship among the angles of a triangle? So if we go through here and we figure out all the interior angles, if I have a third angle, what's the sum? If you look at this, let's just take a quick triangle here. The one thing we should know about triangles, which are really interesting, in fact, let me use a different one. I don't like this one. This is kind of a neat task. If I go through, let's just use, well, this angle should work here. So if I take this, I'm going to go through and I'm just going to copy this or clone it 3 times. Excuse me. And the thing that we could do with these is, this is all the same triangle. You saw that I cloned it. If I take these two here, you'll notice that this angle on the inside right here is the same as this right here, right? I'm showing you this because all 3 angles, they're all the same in this case. If I take this third triangle and I take this thing and I rotate it around, kind of like this, right about, I can't quite get it. Darn it. Right, oh, I had it. If I put it in, I move it down, all 3 of these lines, if I had it right, would make a straight line. If you look at it, this angle here, the right side of it, in fact, let me draw it. So like this one here, the top of it, and the left side of it, they all make a straight line. So that's kind of the proof that a triangle, if I take all the sides and put them together, will equal 180 degrees. And that's why we always say that a triangle has 180 degrees for its interior angles. The next thing I want to do is I want to look at this here. Now, what's interesting is if I know that this whole thing is 180 degrees, and I know that this, for instance, is an obtuse angle, right? So this right here is obtuse. This here is an acute. And this is an acute. And let's just use some numbers here. I'm making these numbers up. I don't have a protractor on this program, but if I look at, let's just say this is 100 degrees. And if this here is, let's just say that it is 40. Well, that means that this other angle would be 100 plus 40, which is 140, and all 3 of them together has to equal 180, right? So I'm going to go through here, and I'll just say that this has to be 40 as well. Now my interior angles here are 180 degrees. It's perfect. If I look here, this is a 180 right here, correct? So if this is 100, that means that this side here is also 40. And this side here is 40. Because if I had my whole angle measurement, I'd have 180 degrees. Now, if this is 40 right here, that means that this right here is also, if I look at it, it's a vertical angle, right? So this would be 40. This right here would be 100. And this here would be 40. So it's 180 degrees all the way around this angle here, right? Like on the top side of it. The reason why I'm showing you this is that this is kind of a continuation of what we did yesterday with our parallel lines and our transversal. Based on this, we could figure out a lot of angle measurements. I have this 40 here. This is also 40, which means that this here has got to be equal to 140, and this is 140. Right here, this is another activity that's in your journal, actually. You could use a protractor. But if I look here, we know that this right here has got to be less than 90 degrees. And it's got to be close to 90 degrees. I'd say like 70. Again, I need a protractor to double check this. And this one here looks as though it is less than 90 degrees as well. I'll say this is 70. And this here looks like it's got to be, well, it's less than 70. So 70 plus 70 is 140. So this has got to be a 40. Again, to get the exact measurements, I'd have to absolutely use a protractor, which we'll do in class. But if this is 70, that means that this other angle measurement has got to be 110. So from here to here is 110. And I knew that because I just took 180 for the line minus 70 equals 110. This one here is 70, and I have to go from here to here to make this straight line, right? So this is also 110. And then this one over here, if I look at it from here to here, again, this is my straight line going down. This is 40. This has got to be 140. And so I'm able to figure all that out based on just my 3 angles on the inside. So let's practice that. What I want you to do is pause the video, try to figure out what the x value should be. So do that. All right, so hopefully you went through and you figured out what each of these should be. Now I have 70 plus 70 is 140, and I have 180 degrees, which is my total interior angles for a triangle. So 180 minus 140 is 40, so x should be 40. And that's the case. This one here, I have 45, 41, 36, 63, and this is 60. This is called an equilateral triangle. It'll be very important later on. You'll notice that all of the angles are the same measurement. So our key idea is x plus y plus z inside of a triangle, in this case, equals 180 degrees. And with that, I can kind of go through and figure out what all of these various angle measurements are equal to. Now these are a little bit easier. I just basically have 3 things I'm adding up, so I'll write it over here. I have my x plus 32 plus 48 equals 180. And then I'll go through. And I'll combine my like terms. So these two here would be 50, so 80. So I have 80 plus x equals 180. I do my subtracting 80, subtract 80, and of course x equals 100. So this should be equals to 100. So if we look at this one here, I have my x plus 28, which is this angle, plus 90, equals 180. And I'm combining like terms. Now I got the 90 from this little thing right here. So I have 2x plus 118 equals 180. I'm going to subtract 118 from both sides to get 62. So I have 2x equals 62. Do that multiplicative inverse or just divide by 2. And I'll get x equals 31. Now to figure out these measurements, remember this is 31, but this is 31 plus 28. So my answer isn't just 31 here. This angle is actually going to be 59. And this angle is 90. And when I add all 3 of them together, I should get 180. So try finding this value and press play. And this one, and press play. There you go. So again, our key idea, we're talking about exterior angle measurement. We know that if I have angle Z right here, this is an interesting concept to think about. We know for a fact that 3 angles equals 180 degrees, right? But with that in mind, we also know that this angle plus these 2 will equal 180. So if I want to figure out what the opposite of this angle is going across, I could add up my other 2 angles to figure that out. Let's just give you an example. So if I said that this was equal to 30, and I said that this here was equal to, I don't know, let's say 70 and 80. Well, if I look at this, this angle, because of the straight line, has to be equal to 150. Would you agree? 150 plus 30 is 180, right? But think about this. What is 80 plus 70 also equal to? 150. That's how they get to this formula, that z equals x plus y. It's always got to be that. So give this a try. If I look here, x equals, now I can figure out what this is. This is 36 plus 72, right? And I could add those up and then figure out what this is and then subtract it and get this. Or I could just take 72 plus 36. If I do that, I'm going to get 108. So this right here is equal to 108, which means that this inside has to be equal to 72. Let's just see how that works. So 108. This one here has got to be equal to these 2 things. So I have 80 plus a minus 5. And these will be equal to each other, right? So let's just set that up and see what it looks like. So if I have a minus 5 plus 80, and that will equal 2a. So let's kind of combine like terms. I'm going to have a plus 75 equals 2a. I'm going to subtract an a from this side and subtract an a from this side. And now I'm going to have a equals 75. And I'm done. This should be equal to a equals 75. And then of course there's two of them. So that means that'll be equal to 150, right? If I look at this one, it says an airplane leaves Miami and travels around the Bermuda Triangle. What is the value of x? So I'm going here, and I have pretty much 62.8. I have 2x minus 44.8. We know that all three of these have to add up to 180. So if I add this up, so I'll have 3x, and then once you combine these terms together, and then we'll figure out what that is, equals 180. Do some algebra. And at the end of it, we'll have x equals 54. And here are the steps. So what's the measurement of this exterior angle? Again, if I take 30 plus 40, I get 70. That's the answer. So we have 70, we have 140, and this is the last one, 54.3. And that